Okay, 8.3, we're going to learn how to find the volumes of um, a certain um, area. And to find the volume, in chapter 6, we learned how to find the area by adding up a whole bunch of rectangles. Now in chapter 8, we're going to find the volume by adding up a whole bunch of areas. Rectangles is two-dimensional. The area would be a three-dimensional object, and they'd be coming out. So you're adding up the area. Okay, these are called the cross sections that you would have to put inside of your integral. The first one is putting squares in that shape, whatever type of shape you have. And the area is x times x is the cross section. These you would have to memorize for the AP test, telling you what kind of cross section that they're putting in the shape. The next one is if these are the legs, it'd be area is equal to x squared. If the diagonals are put in there, it'd be area is equal to x squared divided by 2. Circles is area is equal to pi r squared. This is 90% of finding the volume is using circles. They call them discs. Don't worry about 4. I haven't seen half circles in there. They might want to put equilateral triangles in there, and it's the square root of 3 over 4 x squared. And then this is a washer. This is a circle inside of a circle, which is pi r squared minus pi r squared. And I'll talk about number 6 later as we go. So the first part of the assignment is just learning how to set this up. So we're just gonna set this up to find the volume, and we're gonna use different areas or cross sections in each of these. So here's the first problem. The solid lies between the planes perpendicular to the x-axis from 0 to 4, and it's in between these planes, a negative root x and a positive root x. So a negative root x, or a positive root x and a negative root x, and we're going to 4. Okay, and basically we're gonna come up with a formula for the area of the AX. The cross section are circular discs with diameters in the XY plane. So the formula, we're going to use circular disc because area is equal to pi r squared and pi, and basically you can look in the book too. They have a really nice drawing of these discs in the book, but basically we are putting circles in here, and every circle is different. And basically, the radius is just one of those squared, which would make it x pi for the formula underneath the integral. The next one, I guess this is the picture for this one. I'm going to keep drawing pictures. The next one are squares. Again, if you look in the book, they have a nicer picture, but from here to here is the length of the square, so you're going to use area is equal to x squared, and the length from here to here is 2 root x's squared. And again, look in the book if you want to see the pictures of each of these drawn, which is the same thing as for x. Now the next one are squares using their diagonals. And again, it's hard to put this in here. If you look in your book on page If you look on page 410, you'll see that they put the diagonals in here. Again, I'm not drawing the best picture of it, but the diagonal, the formula for this one is x squared divided by 2, and the diagonals, there's going to be 2 root x's squared divided by 2, which ends up being 4x divided by 2, which ends up equaling 2x. And the last one are the equilateral triangle. Area is equal to the square root of 3 over 4x squared. Area is equal to the square root of 3 over 4, 2 root x squared, because it's again the full length, which is going to equal the square root of 3 over 4 times 4x, which is equal to the square root of 3 over x. So, when you're doing circles, you only need one. What do I mean by one? I only mean from here to here. You only need one. You only need the square root of x. Whenever you're doing this one, you need 2, because you need a positive root x and the negative root x. So you would need both 2 root x's. For this one, you need 2 root x's. You would need 2. And this one you need 2, the length of both of them. So keep that in mind. When you do circles, you only need 1. Okay, let's do an example. Again, all of these are going to be, most of these are going to be circular discs. A circular disc, its area is equal to pi r squared. Okay, so the first thing you're going to do is you're going to graph this. And you're going to go from a -2 to a +2. And the graph looks something like that when you graph it from a -2 to a +2. And then you're going to revolve this around the x-axis. And when you revolve this around, so what you're doing is you're taking this and you're revolving it around the x-axis, so that it makes a vase. And again, if you want to see a picture of the vase, you would have to look on page 404 if you want to see that when you take this object and you revolve it around the x-axis using discs. So you're going to integrate from a -2 to a +2, and you're going to use ax dx. And the formula that you're going to use in there is pi r squared, or pi x squared if you don't want to use pi, doesn't matter, dx. And the pi just comes out, and you're going to go from a -2 to a +2, and it's going to be 2 plus x cosine of x is the radius of, that's the height right here, squared dx. And if you use your F and I and T button after you set it up, use your F and I and T button, and you're going to get 52.43 units cubed. 90% on the 8P test is using circular discs. Okay, the next one, find the volume of y equals x cubed. This is y equals x cubed from 0 to 2. And you're taking this and you're revolving it around the x-axis. And if you take this shape and you revolve it around the x-axis, it looks like a Hershey's Kiss. But it makes a three-dimensional object, like this one made a vase when you rotated it around the x-axis. This one makes a Hershey's Kiss when you rotate it around the x-axis. You're integrating from 0 to 2, and we're going to use circular discs again. The pi comes out from 0 to 2, and the r squared is going to be x to the third squared dx. which is gonna be x to the sixth, from 0 to 2 pi dx, which ends up equaling pi x to the seventh divided by 7 from 0 to 2 if you're doing it your own way, which makes 128 pi over 7 units cubed without a calculator. Okay, another one, find the volume of y equals x minus x squared and y equals 0, revolving this around the x-axis, and the cross-section again is circular discs. You graph this, it looks like this, and you're going from here to here, revolving this around the x-axis. If you revolve this around the x-axis, to me, it looks like you're going to be making a football. If you graph this, this is 0 and this is 1. So we're going to integrate from 0 to 1 pi r squared. Which is equal to 0.105 units cubed. Okay, a couple more. Now this is the change. This is the washer cross section. Again, if you want to see a nice picture of this one, it's on page 405 and 406. I don't do it justice, but you're graphing both of these. A cosine graph looks like this, and a sine graph looks like this. And you only want to go from 0 to pi over 4, which would be in this spot right here. Would be this spot right here where they intersect is pi over 4. Again, they want you to find the volume, and they want you to use circular discs, and they want you to revolve it around the x-axis. When you revolve this around the x-axis, and if you look on page 405 and 406, the shape that you're revolving it around, there's a beautiful picture on page 405 that makes this shape. This is the blown up version of that on page 405. And you're going to take this and revolve this around the x-axis. And the picture that it makes is on page 405. If you look at all of these, this makes a solid base when you revolve this around the x-axis. This makes a Hershey's Kiss, a solid Hershey Kiss. This one right here makes a solid football. But this one, when you revolve this shape around the x-axis, do you see that there would be a gap? There would be a gap, and it would not be a solid figure. There would be a hole. There would be a hole as you're rotating that. And the picture shows the hole. So I want to go all the way back to this page right here. Do you see? We haven't talked about this one yet. If there's a hole, it's the area is equal to the pi, the bigger circle radius squared minus pi r squared of the smaller circle. So what you need to do is set this up, and whenever there's a hole, you need to use the washer method. We are going to integrate from 0 to pi over 4, and the formula is going to be pi big R squared minus pi little r squared dr, or change them into x. So we're going to integrate from 0 to pi over 4, big pi, and the outer radius would be this as you're rotating this around the x-axis, which would be the cosine of x squared minus the inner radius, which would be the sine of x squared dx. And you have to use this if there's a hole. So you could take out your pi since they both have a pi. It's the cosine of squared x minus the sine squared x dx. And it's going to end up being 1.571 units cubed. That's only when you're using the whole. Okay, the last one. A region enclosed by a triangle with vertices 1, 0, 2, 1, and 1, 1. And you're spinning this for the first time around the y-axis and not the x-axis. So instead of spinning this around the x-axis, we're going to spin this around the y-axis. And if you're spinning this around the y-axis, it's hard to see this, but there is a gap. And basically, this is what it would make: an angel food cake pan. It would look something like that when you spun that around the y-axis. So how do you spin something around the y-axis? We're still going to use discs, circular discs. And you see that there's a gap. Okay, first of all, since there is a gap, we need to integrate. And we're going to talk about what we need to integrate, but we need to have a bigger outer radius and a smaller outer radius, dr. So the outer radius is this line. That's the outer one. And this is the inner one. So the equation for that one is a vertical line at x equals 1. And this is an equation, y equals x minus 1. If you keep going through, y is equal to x minus 1 and x equals 1. So x is going to equal y plus 1 is going to be, if we're going around the y-axis, my limits are 0 to 1. Those are my limits because I'm going around the y-axis, and I can put the pi on the outside, and my outer radius is x minus 1 squared. Or no, not using x's, I'm sorry, I'm using y's. I'm using this, y plus 1 squared, minus the inner radius, which is 1 squared dy. If they told you, this is when you, this is going to end up being 4.189 units cubed. That's spinning this around the y-axis. If they want you to spin it around the x-axis, if you took this shape, if you took this triangle, which looks like this, and you spun it around the x-axis, this is the outer one, and this is the inner one. That's the outer one, and this is the inner one. And the outer one would be y equals 1, and the inner one would be y equals x minus 1. And you see that when you're spinning it around the x-axis, it would also have a gap, and it would make a different shape. So, and you would be going from 1 to 2, I think it would be, yes. The limits would be 1 to 2 would be the limits, and it would be pi. The outer radius would be 1 squared minus the inner radius, which would be x minus 1 squared dx. So depending on if you're spinning it around the y-axis, you need to have y's. If you're spinning it around the x-axis, you need x's. So, and those are all the notes for finding the volume using adding up areas.